Good morning. Again, my name is Randall Barney. I'm the Deputy Executive Director for the World Teleport Association. I'm joined today by John Che, Vinod Kaul, and Vaibhav Magao, satellite handovers. The introduction of SSDS adds another layer of complexity, requiring ground segments to be more flexible and responsive to changing network demands. So again, we're going to be using the Slido app, so please submit your questions there. There will also be a poll that we'll look at the end. So we'll start off. What are the most significant technical challenges the ground segment faces in supporting VHTS and software-defined satellites? John, you want to start?
Yep. Hey, good morning. So my name is John from Kratos. So I think many of us are familiar with the traditional satellite. The ground segment is really comprising of the RF gateways and the VSAT baseband, right? So now with a software-defined satellites, you have an added layer of complexity that things start to change in the sky. So I'm going to talk a little bit about the third piece that will be critical in really orchestrating the end-to-end operations for software-defined satellite. So first on the RF gateway side, to be able to support the 200 gigabits, 500 gigabits of traffic, the gateways are moving from our traditional Ka band to the QV band. Right? QV band poses its own challenges on susceptibility to fade, but I think it has been proven, it's working. You need a robust diversity solution, so that technical risk is managed at this point. The second piece is on the VSAT. The holy grail work is really virtualization. You've heard from many panels about virtualization on the VSAT piece. The VSAT has to be scalable. It has to be elastic to be able to spin up and down capability services as and when the business needs arises. Right, so the only way to do this is to go to a full virtualization solution and be independent of any hardware, proprietary hardware solution. That's where Kratos Open Space is pushing towards to. And with a full virtualized solution, that will also allow us to drive a competitive pricing to support beyond your 200 gigabits of throughput that the satellite that these software-defined satellites are talking about. And the third piece is really the end-to-end orchestration. We talk about the space asset is now configurable. It has a flexible payload. It can change the beams, add beams, change powers. So your end-to-end network planning will start have an additional dimension of changes in the space that you need to respond to. So what you need on the ground for a space, for a software-defined satellite is really an end-to-end network planning tool, integrating the space payload configurations, the beam management systems, and the VSAT systems, and all the other auxiliary systems, such as your network management systems, your carrier monitoring systems, to provide a really seamless end-to-end experience of orchestrating a service and providing the SLA that you've committed to your customers. So those are the three key pieces of any SDS that we're talking about today.
Yeah, I think John's kind of given up most of the stuff out here. I don't think it's much to add to that. The challenges that most of the times you have conversations around really is in terms of people, most of the satellite operators being able to put their hands around and say, what do they want to do with the flexibility that you get on the SDS? So how does it apply to them in their use cases, in their business cases, and how do they actually build coverages in geographies where they are interested in doing business? So I think that's most of the part where the challenge really lies. I think technically the equipment, the technology, everything is there today available to be able to monetize the capability of software-defined satellites. So I think it's just that the industry is a little delayed. These launches should have actually started taking place by now, and some of these should have been deployed by now. But I think in a couple of years we'll get there. But the challenge is on actually defining the business cases, use cases of how do you actually deploy this. So most of the times when you speak even at conferences or anybody comes up and says, hey, how do you actually, we understand it's flexible, we understand that you can do all of this, but then how do I actually use this to offer a service? How do I actually build the flexibility? We hear lots of examples about moving beams or moving capacity as traffic merges for mobility and things like this. But really getting down into surface orchestration, how actually that would be deployed, how over time you could start maybe with very little capex. You don't want to light up all the 100, 200 gigabits of capacity. You want to light up much smaller capacities and then progressively deploy, your hardware, your capex, or your cloud infrastructure. So those are the more common conversations that end up having.
Vinod?
Yeah, hi, thank you. Good morning, everyone. My name is Vinod from Gilad. Adding to what John and Weber have said, that one of the key challenges today, just to give an example of MPOWER, it has close to 5,000 beams per satellite, each beam of 100 gigabits, and 11 satellites. So the challenge is, how do you, end of the day, combine all these beams, all these megahertz, to deliver optimized Mbps to the end user and to the application which the end user wants to use. And second is the ease of operation. So the challenge is how the ground segment and the space, the new software-defined satellites, they work in harmony. And that's what Gilad has been doing when we deployed the MPOWER. It's a live example where orchestration, software-defined beams, everything is in use today, and that has been deployed from last few months. And it's an interesting live example where the ground segment and the satellite, software-defined satellites, have been working in harmony.
Okay, great. How can ground stations be designed or upgraded to manage the dynamic capabilities of SDS while maximizing throughput potential for VHTS? Vinod, do you want to?
Okay, so basically what John said in the beginning note, that one of the key things when you look at how the ground segments have to cater to VHTS requirements is when you have, as I said, thousands of beams, and then you have they are all dynamic, where it's in couple of years back, everything was stationary. Today you have aircrafts, ships, everything is mobility. So an aircraft comes into a beam and exits a beam, and the beam has to be given to be optimized for a few hours for something else. So the ground station has to be really dynamic, and I think one of the key elements which defines that is the orchestration part of it, where the NMS and the orchestrator plays a key role. How do you optimize? How do you understand the whole map of the beams, of the way the traffic is generating, fading, and accordingly connect to the baseband side and optimize and dedicate resources, change on the fly, and end of the day, the whole thing has to be automated. The NMS has to be real time, looking at everything and delivering and doing it automated way.
So the conversation actually starts from understanding the gateway spectrum that's available. On the slot, they're going to put these satellites. So most of the satellites are going to come out a cookie cutter, right? So you can take them and put them anywhere. You're going to decide whether you're going to do a KA, QV, KA, and a KA band user beam, or you're going to do it as a KU band user beam. So the user beam depends upon, obviously, what kind of slot, what kind of spectrum the operator has. But the conversation always starts from the gateway spectrum. What gateway spectrum do you have? So at the maximum today, if you look at QV, KA band, you have typically about 15 and a half gigahertz of spectrum on one pole. So you put both the poles together, you get to about complete 30 gigahertz of capacity. And that's when you start looking at, okay, now with my QV band beam, where do that goes on your uplink and your downlink coming down from the satellite, but then how does that get into my user beams? How many user beams am I going to generate at start of my deployment, at the start life? So yes, you can do lots of beams. We get use cases where people come and say, oh, I want to do 500 beams. It's a really large number of beams. But at that point, you're getting to really, really small pencil-shaped beams. So you're putting up a lot of capacity, and really, really pinpointing it into particular places. But when you start, you may not have a very well-defined target customer base, or you may not really know where that capacity is needed the most. So you'll be a little bit more generic. You'll have much larger beams. You may have lesser number of beams. You may not want to put all your capacity in and say, okay, I'm going to actually deploy all my capacity. You may just say, I'll probably deploy 20% or 30% of my gateway capacity. So that's where the conversation starts from. And it grows into the rest of the gateway beams that are on the satellite, typically 4 QV Ka-band gateway beams in the current generation of SDS satellites that you'll see. And from there, you start working with the satellite operator to say, okay, how do you want to size up your network infrastructure? How do you want to build it up? And what do they see in the midterm to long term, this network growing, in terms of flexibility scenarios? So you would want to make sure that the gateways are architectured and built towards that vision. One of the challenges that we have specifically in countries, in regions like Asia Pacific, is most countries demand an in-country gateway to get licenses. That sparks a very unique challenge wherein for QV band, right, the diversity schemes that you can use, right, get a little bit more complicated. Let me explain that. Today in Ka-band, what we do very commonly is we use diverse RFTs, 2 sets of RFTs, primary, secondary, and we manage the availability of the Ka-band gateway, uplink and downlink beams. But in QV bands and Ka-bands, the antennas are really expensive. The RFT could be $6-7 million. It's a big expense. So it's a luxury to afford RF diversity. So you just can't go and do 2 RFs everywhere. It's challenging. So what flexibility the payload then can give you is you can actually hop your gateway beam onto another QV Ka-band gateway beam. So that way, if there's inclement weather, you can move on to the next gateway. Give you an example. We have got maximum number of QV band RFTs that we uplink on Jupiter basebands. We have our own Jupiter 3 satellite. We have experience with Eutelsat. Our experience, and this is just general sharing with you guys, is if you say that in a rainy season, Ka-band would experience 8 or 9 outages, 10 outages in a rainy season. QV band, you could get 8 or 9 outages in a day. So the quantum factor and the diversity schemes that you need to set up to make sure that your gateway beam stays up, running, your user beams stay connected, your customers and your remotes do not get any outage, do not experience any outage when you flip from one gateway beam to the other gateway beam, is one of the first levels of flexibility and the first levels of capability that you need to build in your gateway systems. That's just the first start of it. So sitting down with your customer and deciding where their coverages are, which gateway beams they have, how are they going to architecture this, and how do you want to build that over the lifetime of the satellite. So these are the kind of conversations you tend to get into, and there's not just a scenario that you need to build. There are so many different scenarios. There are so many different business models that the satellite operators want to chase. It's not about just doing fixed broadband or enterprise. It's about doing, aero, IFC, mobility, sometimes government. So there are so many different use cases, and each of these will drive different kinds of decisions and choices in your ground infrastructure. So this is just, I would say, the tip of the iceberg of the conversation.
John, do you want to add to that?
Yeah, maybe I'll just add on a brief, just a little bit more on what is the dynamic a software-defined payload means, right? So we do not really we have yet to have a software-defined satellite in the space today, but Kratos, we are already developing these orchestration tools, these end-to-end network resource planning tools for a couple satellite operators. And we're going through a lot of use case, business case discussions on how do we optimize, harness the capability of the software-defined satellite that they provide, right? I'll give you an example. A traffic pattern, the traffic utilization of any beams will change over a day, in the daytime and the nighttime. So how can you now, as an operator, overbook capacity by adjusting the power of the beams according to the utilization that fluctuates throughout the day. And you can start shifting the power to beams that will start having the capacity growth. So this overbooking will allow an operator with 100 gig, 200 gig satellites, and with proper management, right? Proper orchestration, automation on the ground, which is really a software-defined ground, to be able to overbook the capacity that you can sell to your customers, maintaining the SLA that you're committed to, and generate additional revenue from the software-defined satellites. So these are the use cases we are engaging all our customers that we're working with on our Norman and Osman orchestration tools to help to realize the potential benefits of these software-defined satellites capabilities. All right.
All right. Well, sticking with automation, what role will AI and automation play in optimizing the operation of ground segments for VHTS and SDS, especially in real-time decision-making?
Yes, so I'll just start right here. So I talk about the changes within the day, right? So not everybody will make changes in a day, right? Vibha mentioned about how you start off a satellite with a broad beams and slowly change them into spot beams as your capacity grow. So all these changes will need to have certain intelligence on the ground. And this ground infrastructure will need to be able to integrate to the satellite, to the VSATs to make all these changes. And AI plays an important role. There's tremendous amount of traffic, amount of data that will be generated as you operate this. So the AI will allow you to manage the spectrum capacity, optimize those. It will allow you to even look into a multi-orbit operations, how you can deconflict multi-orbit operations. It will allow you to predict outages based on meteorological data that comes in. So AI will continue to be a big feature on the software-defined ground to provide the intelligence and the automation you need to really provide a seamless end-to-end experience.
I think AI, deep learning, data lakes, these are all going to flow very rapidly into our industry. Let's just look at the change that we're talking about, the disruption in the room here. I don't think 3 years ago anybody would have thought 4 million users on Starlink. And I think everybody today, when they make a business plan, the benchmark and the target for what they would want to serve as has gone that high. How many subscribers am I going to serve? How many sites am I going to have in my network? And the bar has been set yay high. Now, we've all seen in our industry people managing networks with thousands of sites, and we all know what it takes for NOC managers to sit and work through outages, customer issues, network problems, proactive monitoring, proactive management. But now you start taking that to a volume of 4 million. And now you can realize what AI will do for you and what deep learning will do for you. It is going to basically look at, and we've already started doing that at Hughes, is the AI for us keeps looking at what's happening in the network, what are the problems that are most likely going to take place. So before even the customer knowing that there could be an outage or there could be a brownout in his network, the network management, the people behind the network management systems can actually act and take proactive steps. So all of this is where I think the most meaningful amount of AI will start coming in first. Though the scenarios in terms of being able to do all of this flexibility are tremendous, I still feel that all of the planning engineers in satellite companies who have done this, and they take 5 years to build business plans today, right? On a traditional satellite, right? Spectrum management, how are we going to divvy up the spectrum? Where are we going to put our spectrum? And it stays static for 15 years. Telling them that you want to make that split-second decision as to where the power will go, it's mind-boggling right now. So people are still soaking it in. The confidence level is not very high when we speak to people to be able to do that fast right now. But yes, once the satellites are there, once people actually get their hands on it and they understand what are the nuances, what are the trade-offs, those things will get there. So I feel the first level of confidence in using AI will come more on the operation side. And automating, reducing cost, making sure there's a seamless service to customers, subscribers at the end of the day. And then the volume of the business going up, the number of subscribers, the quantum of bandwidth you're managing, the number of channels you need to manage, return channels, the number of channels you have. All of that is going to lead to, it's impossible for humans to look at it. It's too much of grunt work. And I think that's where AI and deep learning will come in.
Just to add what Vaibhav said, that there's a dynamic change in the way the traffic, the channels, the beams to be handled by the ground segment, and with the platforms offering a global service, in the MEO and the LEO world, and every beam to be monitored and they have to be optimized. End of the day, the whole mechanism is to how do we optimize the capacity to deliver it to the end user at the right price points. So the AI thing is a developing phenomena, what I see, but automation, which is currently happening, which is currently inbuilt in the systems where NMSs are highly flexible. We offer an elastic NMS where predictive learning and pattern learning is part of the delivery. And today the AI will take over as Vaibhav said, that there are more and more automation gets and AI will take over. But today, automation is inbuilt, but AI is a new phenomena which will come into the systems as AI becomes more mature.
Great. We're just about out of time, so we're putting up our poll here. What do you see as the biggest challenge for the ground segment in supporting VHTS, SDS capabilities? Looks like integration of satellite software-defined payload.
That's pretty accurate, actually. Pretty accurate. Both of those, cost effectiveness in terms of, how do I get my ground segment investment, and then how do I get the TT&C and the VSAT system NMS. So when you make changes simultaneously, the spectrum and the beams on the satellite also change, and the ground system also adapts to it simultaneously. And that's the integration part that the audience is pulling up.
Okay, great. I think we do have time for one audience question. Peter, you had a question. There we go. The software-defined satellites are behind schedule. What effect, if any, has this had on your businesses?
Well, actually, from Kratos' perspective, we are a ground supplier. The impact to us is a lot of programs are all shifted to the right. That's the biggest probably cause of concern for many of us who are deploying the ground segments, right? With all the delays of the software-defined satellites moving to the right, business cases have changed. Some will not even be able to build a business case that is valid for 5 years down the road to wait for the launch. So those are big concerns within the industry to see how we can get together to really come together in view of the LEO constellations that's coming in. Last night I was just reading on the LinkedIn, there's another constellation that's just being launched again, right? Logos Space, right? So there's just endless amount of LEO constellations that's coming up, and for regional operators leveraging a multi-orbit, still going with GEO, they need to be able to better plan the resources. The big satellites are still going to give you the cost effectiveness, but we need them to be on time. We need them to be able to deliver capacity with the software-defined capabilities such that they are not locked into something that change in the future.
I just want to add that, basically the ground segments are kind of geared up to handle software-defined satellites. And I do understand that, I agree with there's a delay in some of the launches. and it has effect on the business, on the revenues, and definitely there is a need to, as an industry, to see how it can be made move forward.
Yeah, I agree with that one. Nothing more to add.
All right, well, with that, we are actually out of time. So please join me in thanking our panelists.